Hi students, welcome to the session on array of 2-point sources with equal amplitude and phase. Right? So first what we are going to see here, we are going to have an antenna array of 2-point sources. What is point sources here? Here point sources is nothing but our antenna only. Fine? Then why it is called point sources? Let us see. Which are fed with equal amplitude and phase. Okay, you see here we have 2-point sources, one point source 1 here, point source 2 here, this is a reference R. Okay, so we want to obtain observe the radiation at this point P, which is far away from antenna 1 and 2, right? So we know that sun radiates, fine, and here we are there, so the distance between the sun and the earth is too far away, too long, right? So sun appears like a point, but the size of the sun is too bigger than but it appears like a point. Like that, if we observe something far away from the radiating source, then the source becomes point source. That's why here the point P is too far from the antenna 1 and 2. So the antenna 1 and 2 become point source, right? So the antenna 1 is located at a distance of d by 2 from the reference antenna. Similarly, point source 2 is located at a distance of d by 2 from reference. Okay, so now let us see path difference. This is the reference. The distance between the reference and observation point is r. The distance between the point source 2 and observation point is r2. The distance between the point source 1 and observation point is r1. Right? So now we see the path difference between this R and the difference between R and R2. What is that? This is the difference. Yes or no? This is the difference. What is the difference? We can see path differences between R and R2 is R minus R2. That is given by d by 2 cos theta. R is this distance, R2 is this distance. So if you subtract R2 from R, you will get this distance. Okay, how it is d by 2 cos theta? It's a right angle triangle. This is theta, this angle is theta, here you see. So cos theta is equal to what? Adjacent. So this side is adjacent. Let us assume this is x. So adjacent side is x, hypotenuse is this distance, that is d by 2. So what is my adjacent side? X is equal to d by 2 cos theta. So that's what this distance d by 2 cos theta x. Similarly, what is the path difference between R and R1? So R1 is traveling along R1 minus R is also d by 2 cos theta. You observe here you see, follow the simple, this is d by 2, this is theta. I want this distance, total distance is R1. If you subtract R, what you get is this distance y. So that is equal to, let us assume that is y. Y is nothing but our d by 2 cos theta. Clear or not? So the path difference between the reference and point source 2 is d by 2 cos theta. Path difference between R reference and point source 1 is d by 2 cos theta. So the path difference between 1 and 2, total path difference is total path difference. I call that is psi. That is d by 2 cos theta plus d by 2 cos theta. Fine. So between 1 and 2. Psi is equal to d cos theta. Fine. So this we must know. Okay. You see, when the antenna radiates, right, all the three, the radiation starts from all the three at the same time. One, this is reference, this is 2. What will happen? The radiation from 2 reaches point P first, then radiation from R will reach, then radiation from 1 will reach. So in the order of first 2 will reach, followed by R, then by 1. Clear or not? So point source 2, the radiation from point source 2 will reach point P first, then radiation from R, then radiation from 1 will reach. So there is a path difference. Okay, that path difference we found. Okay, d cos theta. We all know that path difference is directly proportional to phase difference. Okay, so I call path difference is not psi, please change it. I call phase difference is psi, so path difference I call, that is, I keep as it is, right? So phase difference. Okay, so phase difference is direct, or path difference is directly proportional to phase difference. Phase difference I call as psi. That the psi is phase difference, not path difference. Psi is directly proportional to d cos theta, right? So this indicates psi is equal to bd cos beta d cos theta, where beta is a proportionality constant. And we know beta is equal to 2 pi by lambda d. 2 pi by lambda into d cos theta. So this is what psi, path difference, sorry, phase difference. Phase difference is psi. Psi is a phase difference. Or you can say psi is equal to beta d cos theta. Okay. Now we will start derivation. Right. Let us assume that electric field at point P is E1. So E is for electric field at point P due to point source 1. Similarly, E2 is for electric field at point P due to point source 2. Fine. So what is the total electric field? Total electric field is written as E is equal to E1 e power minus j psi by 2 plus E2 minus j psi by 2. Why I am writing like this is we know psi is equal to beta d cos theta. So psi by 2 is beta d by 2 cos theta. This indicates psi by 2 is proportional to d by 2 cos theta. This is what phase difference. This is what path difference. Already we know phase difference is proportional to path difference. This is we have studied from our school days itself. Alright. So what happens here? What is the meaning of this equation then? You see, this indicates, we know the radiation from point source 1. Okay, this is e power plus j, it is plus. Okay, we know the radiation from point source will reach later. I told you already. Who is reaching first? The radiation from point source 2 will reach first. The radiation from point source 1 will reach point P later. So radiation from point source 2 leads, radiation from point source 1 lags. So you see, this equation indicates, right, we know the radiation from point source 2 leads, so path is less, so it is right. So this indicates positive, or the radiation leads, electric field leads, it comes first. So path difference is proportional to phase difference, it lags, right? It indicates E1 lags. This equation indicates E1 lags reference by psi by 2. As of course, right? We know this is reference, this is point source 1, this is point source 2, right? First 2 will will reach, 2 will reach, then radiation from reference will reach, then radiation from 1 will go. So this psi by 2, this minus psi by 2 indicates the E1 lags reference by psi by 2. This indicates E2 leads reference by psi by 2. That is very important point to be noted. Now hereafter the derivation is very simple. But you see E is equal to E1. E1 is the electric field due to source 1. E2 is the electric field due to source 2. But we know both are fed with the same current. So the field will be same. Only phase will be different. So E1 is equal to E2. So E1 is equal to E2 is equal to E0, because source 1 and 2 are fed with the same current. Same current means they will produce same magnetic field. Same magnetic field will produce same electric field. So E1 is equal to E2 is equal to E0, right? So the amplitude will be same. Amplitude of E will be same at P, but phase will be different. See, the best example I can give for, logically I can give the example. See, when sun radiates, let us assume we are in the same city, right? In nearby house of 1 kilometer away. So this is X house, this is Y's house, right? What will happen? The distance between them is 1 kilometer. But this distance 1 kilometer is very small compared to the distance between the earth and the sun. So what will happen? Even though what the person in the house X and Y will feel, they will feel the same temperature. But that means amplitude of the temperature is same. But here the radiation will come yearly. Here the radiation may come after some time, or here it may come yearly. Here it may come after some time. So the magnitude will be same at distance point. We feel that it is same, more or less, right? But phase will be different because of the path difference. That's the simple logic. So we can directly say like that also. So E1 is equal to E2 is equal to E0. So now we substitute. So this indicates E is equal to E0. E0 I take it outside. E power j psi by 2 plus e power minus j psi by 2. Okay, what I did here, I simply replace E1 and E2 by E0 in this equation. So let us assume this is equation number 1, this is equation 2. Fine. So substitute 2 in 1, we get this one. Fine. We know e power plus j and e power minus j, that will give 2E0 cos psi by 2. We know psi is equal to cos beta d. Psi is equal to beta d cos theta, right? Beta d cos theta by 2. Psi we know. Psi, I will substitute the value of psi here. Right, this is the equation for electric field. This is the equation for electric field at the distance point due to 2 point sources, right? So this is very important equation. Okay, so here this is the maximum amplitude of the electric field, right? So if you want to normalize, what you have to do, you have to divide the any value by maximum value. So E by E max, that is what E normal. Max is the maximum electric field amplitude, E naught to E naught. So if you divide E by 2 E naught, divide electric field by maximum electric field, that is what normalized electric field. So it will be cos beta d cos theta by 2. Fine. So this is normalized value. Okay, now we know beta is equal to 2 pi by lambda into d by 2 cos theta. So what will happen? beta d lambda, right? So d is the distance between the point source and the reference antenna, right? So d is equal to lambda by 2, right? So d is nothing but distance between reference and point source, that we know. So that is lambda by 2. So lambda cancel, so it is cos pi by 2 cos theta. That is what En, or simply E. Okay, so this is what electric field due to what you call two identical point sources fed with the same current and the same phase. Now you see that let us take let us put one table here, theta value, here E value. When theta 0, what happens? When theta 0, what will happen? Cos 0. Cos 0 is 1. So you substitute here, right? When theta is equal to 0, cos 0, cos pi, then cos 0 is 1. So cos pi by 2, cos pi by 2 is 0. When theta is equal to pi by 2, what will happen? This is cos pi by 2, 0, cos 0, 1. When theta is equal to pi, cos pi is minus 1, so cos of minus pi by 2, 0. When theta is equal to 3 pi by 2, what will happen? Here you see, when theta is equal to 3 by pi 2, again is it 0? It is 1. 3 cos 3 by 2 is 0, so cos pi by 2 into 0, 1. So this is what we get, right? This we draw as a diagram. Fine. So cos 360 or 2 pi, again it will repeat 0 only, right? Cos 2 pi is, right, when you substitute cos 2 pi is 1, then cos pi by 2, 0. Now then we will draw one more value. What will happen to 60 plus or minus 60, right? When you substitute cos 60, what is cos 60? When you substitute theta is equal to 60, it will be cos 60. Cos 60 is nothing but 1 by 2, so it is cos pi by 4, right? So cos pi by 4 is nothing but 1 by root 2. Fine. So similarly, cos of, when you substitute cos equal to minus 60 also, it is cos minus pi by 2, that is also 1 by root 2. Similarly, for cos 120, theta is equal to 120, if you substitute plus or minus, what it will become? They will become 1 by root 2. Right? Substitute the value and you get the answer. Instead of theta here, substitute 1 by root 2. So you will get this. Now if you draw the diagram, that is called radiation pattern. Right? When theta 0, this is theta, x-axis 0, theta, y-axis E. When theta 0, what will happen? It is 0 only, right? When theta is maximum, it is pi by 2. Wow. When theta is pi by 2, 1. Right? So this is what happens, right? It is 0. Theta here, theta varies from here to here, right? It's going like this, like that. Okay. So when theta is 0, it is 0. Fine. When theta is pi by 2, it will be 1. Theta 90 degree. Right? When theta is equal to pi, it is 0. Fine. So theta is equal to 180 degree. This is theta is equal to 0 degree. That is here theta is equal to 90 degree. Fine. So what will happen here? Theta my 270. Fine. So what I am doing, let me draw the diagram, then we'll explain. it will be like coming like this. Okay, it's not coming properly. Let me draw clearly. Right. So the pattern will be appearing like this. Why you see here when theta, okay, I'll draw somewhat bigger, then only it is easy to realize. Okay. It is somewhat big we need. I think this is okay. Right. Here it is wrong. Okay. So what happens? Still we have to draw something. This is 60 degree. Right. Right. So here you see 60 degree. Here when theta is equal to pi by 2, the electric field is maximum. You see this is electric field value. This blue is representing electric field pattern. Right? When electric field pattern is maximum when theta is equal to 90. Yes or no? When theta is equal to pi by 2, it is having a value of 1. Maximum value 1 here. Right? When theta is equal to 0, here theta is 0. So here it is having a value of 0. Right? When theta is equal to 60, its value is 1 by root 2 of maximum value. 1 by root 2 into 1 I can write. So it is 1 by root 2 of maximum value. Similarly, when theta, this is what 60. Right? Similarly, when it reaches 120 degree, here it is 120 degree. The value is 1 by root 2 of its maximum. I can write 1 by root 2 as 1 by root 2 into 1. So 1 by root 2 of maximum. Why you understand why I normalized? Because when power is dropped to 1 by root 2 of maximum, that angular difference is given by, we know, half power beamwidth. So this is what half power beamwidth of your antenna. So this is the way we can find. When theta is equal to pi, again the radiation will be 0. So theta is equal to 180, the radiation is 0. The blue color resistance to 0. When theta is equal to 3 pi by 2, here it is going to 1. Right? So, okay, cos 2 pi is minus 1. Sorry, it is minus 1. So, this is theta. Fine. So, 270 degree. When theta is equal to 2 pi, again it comes to 0. Right? So, this is what the radiation pattern of this antenna. Similarly, half power beamwidth can be drawn for downside also. It is coming like here, coming like here. Here it is minus 60 degree. Here it is minus 120 degree. This point. Fine. So this is minus 60 degree. Right. So at minus 60, what's the value? Right. It is minus 1 by 2. Here it is plus or minus. Here it is plus or minus. Right, plus 60 plus 1 by root 2 times of maximum value, minus 60 minus 1 by root 2 times of maximum value. So here this point and this point. So you can find this angular differences of power beam width. Right. So this is like a typical broadside array antenna pattern, because we know in broadside array the array pattern is perpendicular to the direction of radiator. So here it is like a broadside array pattern. If two isotropic radiated isotropic sources are radiated by equal current and equal amplitude current and phase, then we will get a broadside array pattern. Right? This is what we must understand about two isotropic array sources with same amplitude and phase. I hope you understand this concept. If you have any doubt, please ask me in comment section. I will clarify. Thank you.